This is a 240 kilowatt solar power station, and it can power many homes, businesses, industries, and even heavy equipment. But what exactly is inside a solar power station this powerful? Let me show you. In places like Nigeria, power supply is very unreliable, and running generators at this scale is extremely expensive. That's why many people are transitioning into solar energy. But many people don't understand what makes a large system like this to actually work. And that lack of understanding leads to poor design, wasted money, and system failure. Now let's break down the key components that makes up a 240 kilowatt solar power station and how they all work together. Starting from the solar panels. The solar panels is seated on four ground mount structures, and we have about 400 units of 625 Jinko bifacial solar panels. Then in this ground mount structure, we have 100 units of 625 Jinko bifacial solar panels, and these solar panels is connected 14 in series. We have 14 panels in series and 7 in parallel. As you can see, it's a bifacial solar panels. When you hear bifacial solar panels, there are solar panels that can generate electricity both on the front and the rear side of the panel. And the rear side of the panels at optimal condition can produce about 30% extra energy. Now we have the PV combiner box, where the whole strings of panels is connected in parallel. Like I said earlier that we have 7 strings of panel connected in parallel in this PV combiner box. Then the output went straight to the hybrid inverter. Now here we have the batteries. In this power station we have 48 units of lithium iron phosphate batteries. This is a high voltage battery system. This batteries is connected 16 in series, and each battery is 32 volts. Here we have the controller for the first cluster. The first 16 batteries in series. It helps to make sure that the whole batteries in the series charges with the same current and discharge the same current. Then here is the current sharing cable. This cable helps to share the current among the 16 batteries. Then here we have the BMS, the battery management system. It helps to make sure that there is even distribution of current among the cells of the batteries. So each of these batteries has its own battery management system. Then we head over to the second cluster. Another 16 batteries in series, looking out for 512 volts nominal battery voltage. We also have the controller for the second cluster. Now here is the third cluster. Another 16 batteries in series with nominal battery voltage of 512 volts. Then this is the controller for the third cluster. Then this is the battery combiner. In the battery combiner dashboard, you can see the cluster number 3, which means that you have 3 clusters. The first cluster, the second cluster, and the third cluster. Cluster number is 3. The state of charge is 98%. Then the amp power of this battery is 945 amp hour. Then you can see the battery voltage 534.0. Then the current 35.4 amps, which is what the battery is charging with. For the inside of the battery combiner, you see the controller that manages all these batteries. Then also you can see where all these batteries is connected in parallel. For the positive terminal, we have two 250 amps fuse with 750 volts DC rating. And also for the negative terminal, it is connected using a bus bar. You have 2 breakers for the batteries, which isolates the battery from the inverter. This down bus bars is where the battery is connected to the inverter. Then this is the earthing for the battery combiner. As you can see, the actual energy is 483.84 kilowatt hour. The capacity is 945 amp hour. Then the rated voltage 512 volts. Then it has maximum discharge current of 0.5 C and recommended charging current of 0.2 C. Now we head over to the inverter. In this power station we have 2 units of ATESS power HPS 120. This is the first inverter and this is the second inverter. This is a hybrid inverter with a continuous output power of 120 kilowatts. You can see the screen of the inverter. The solar panel is bringing in power. And also this is the second inverter, the same ATESS power HPS 120. This inverter is combined together to have a total output of 240 kilowatts. And this inverter has an isolated topology, which means that it has inbuilt isolated transformer, which isolates the DC input from the AC output. Then we head over to the inverter combiner, where the 2 ATESS power HPS 120 is combined together to have a total power output of 240 kilowatts. Then we go over to the fire suppression system.
Here we have the gas cylinder and also electrical actuator on top and the gas pipe. This fire suppression system helps to suppress fire. In case of fire outbreak in this power station, this fire suppression system will quench the fire automatically. This first smoke detector will detect the smoke, and when it detects the smoke, it sends the information to the controller, which I will show you later in this video. Once the controller receives the information, it will have to wait till the second smoke detector detects the smoke also. Once the second smoke detector detects the smoke, it will send information to the control panel that this fire is serious. Control panel will now trigger the actuator to discharge the gas. And once the actuator punches the gas cylinder, it will discharge the gas through this pipe and it will suppress the fire inside this place immediately. This is the fire suppression system control panel. This is where the smoke detector sends information. So once the smoke detector sends information to this control panel, it will be able to trigger the actuator to discharge the gas. Then down here we have two buttons. We have the blue one and the yellow one. The blue one is for you to abort the gas. Let's say for example that there is smoke inside this place and the control panel wants to discharge the gas. Somebody that is around at that moment can press this button to stop the gas from discharging. That is the gas abort. Then in case that you come here and see that the control panel has not taken care of the fire, you can press this button immediately to discharge the gas. These two buttons helps you to handle the fire manually. Here we have the fire alarm bell. This fire alarm bell creates awareness whenever there is fire outbreak in this solar power station. The controller will trigger the fire alarm bell, so it creates awareness. When it creates that awareness, people nearby will be able to know that something serious is happening and urgent attention is needed. Another crucial component of this solar system is the cooling system. In this power station, we have two AC units that make sure that the inverter and the batteries operate at its optimal temperature. We have these cooling units that helps to bring down the temperature. This inverter, like I said earlier, is an industrial inverter. During its operation, it emits a whole lot of heat. Then also we have the heat extractor. The heat extractor helps to take away the heat inside this inverter room to the outside world. And also we have another heat extractor right here. It helps to take away heat outside. And here we have the data logger. This sends all the information on the inverter to the internet. Once it is connected to the internet, it will be able to upload all the information in the inverter to the internet. So once you have the login details, you can easily monitor this system anywhere in the world. Now you have seen what's inside a 240 kilowatt solar power station and how each component plays a role in delivering reliable power. If you are thinking about solar, understanding system at this level will help you avoid costly mistakes and build something that actually works. If you find this video useful, do well to like, share and subscribe to my YouTube channel. Turn on your notification button so you'll be notified when I release videos like this. See you in the next video.